Now that everybody's had their positive presentations, I'm going to go on the negatives, which is, unfortunately, what's happening in the amphibian world, right throughout the world. Some of the species which have already gone through today, we'll go through them fairly fast: growling grass frogs, pollywonks, striped marsh, spotted marsh, Ewing's tree frog. We used to call it the southern brown tree frog, but then we found green ones. So we stopped calling them brown tree frogs now, we call them Ewing's tree frog. Striped marsh, Bibberance toadlet, which is an endangered species in Victoria. Again, showing identification markings. The most common frog in Victoria, common froglets. Actually, the numbers, it's interesting actually, because the numbers of common froglets have gone through the roof since growling grass frogs just about disappeared in the late 80s. This is one of the wetlands that I was monitoring right up until, well, the 204 there, but it's gone on since there. Growling grass frogs, for example, one of the things I've been sort of concentrating on. Up until 1989 were extremely common. They're all over the place. And all of a sudden, within up to 92, they just have disappeared. Now they're fragmented right throughout the state, and that's really not good genetically because they don't intermingle. So, but they did come back for a little while, but there's problems since then, so we'll keep going. That's where they've been recorded, although there are a few more recordings since there. You'll notice there, particularly around the Melbourne area, there's a lot more of those green spots there, mostly because there's a lot more monitoring done of growling grass frogs around the Melbourne district. The major reasons for the disappearance of a lot of the frogs, 2/3 of all wetlands over 5 acres in Victoria have been drained. 5 acre wetlands and less than 5 acres weren't even taken into account. So about 90% of those have disappeared. Air pollution's another one, which knocks off frogs because they transfer oxygen through their skin. They pick up air pollution. Water pollution, of course, which has been mentioned quite a bit today. And mosquito fish is another one, which has been mentioned quite a few times. Domestic stock. Destruction of habitat, which we'll go into shortly. Chytrid fungus, which I'll go into shortly again. Ultraviolet radiation, which they've found has been detrimental to amphibian populations, which I'll show you some slides of that as well. Air pollution, of course, it's not even too good for us, or this one. You start breathing that sort of stuff into your lungs, it's not too good. Well, it's even worse for frogs. Also, chemicals, of course. You'll notice how many legs this frog's got. One in particular, which is atrazine, has now been approved in Australia for continued use, which is extremely detrimental to amphibians. These are slides from America. You can see how many legs and deformities it's causing, but also it changes the sex of frogs. Males can turn into females, so it's really changing them hormonally. So lots of research needs to be done on this sort of thing. Oil pollution, a lot of people draining their car into the drains, down into the local creeks, drainage lines, kills off frogs. This is a fish kill. Two things: water pollution to start with, but then it also depleted the oxygen in the water, so a lot of the fish died as well. Also, one that I haven't got a slide of here is blue-green algae. Probably about 15 years ago I was up along the Darling River, and it was just one swathe of blue-green algae. There were kangaroos dead all over the place, but also there were lots of frogs that were dead. And even though that blue-green algae dispersed, once it does burst, it releases the toxins into the water, which of course the amphibians pick up. And we must have found at least 5,000 frogs that were dead along the Darling River. Salt, get salt too high, not too good for frogs. Although, we're talking about the amount of salt which frogs can breed in. They can't breed over, usually around about 4,000 EC they can't breed over. And yet frogs will adapt themselves to suit the timing. For example, in Bull Lagoon over in South Australia, the salt levels get up there to about 25 to 30,000 EC. But the growling grass frogs there don't breed when the salt levels are so high. They breed earlier when the the lagoon first fills up with fresh water, they breed, and then the tadpoles themselves seem to time themselves on the amount of salt that's building up as it dries out, and by the time it's too high, the froglets are actually out of the water. Atrazine, which I was just talking about a minute ago, quite a widely used herbicide on crops. Mosquito fish, of course, male on the bottom. We've already talked about those. But also trout. Trout are a great lover of eating frogs and frogs' eggs. Redfin, the same. Foxes, particularly on growlers, we found about 5 years ago we were doing a study on fox predation, and we found around wetlands, growling grass frogs were very high on the menu. And cats. But they also take eastern Bay bandicoots, which is another species I'm working on. Okay, out of the 5,800 species that are in the world, 2/3 of those are in trouble and 1/3 are critically endangered. Mainly through chytrid fungus, which I'll go into shortly. Draining of wetlands is extremely important, as I said. This is a wetland that was literally cropped. Once it was cropped, the natural vegetation disappeared and it was useless as far as the wetland goes. Erosion, this is sheet erosion, which literally covers the vegetation and just destroys the habitat. Deer, of course, plugging up the edges of streams and the vegetation. Feral pigs, another one that really dig up a lot of the wetlands. Up in the Hay area, a lot of the frog species up there have declined dramatically because of the feral pigs that are up there. But also a lot of people bringing pigs back down, for example, in the elm in the forest south of Ballarat. People brought down pigs and let them go into the forest there, and they've destroyed quite a lot of the wetlands through that area, and the frogs' numbers have declined dramatically again. But there's a good way of getting rid of them. We just introduced crocodiles to the area. They enjoy feral pig. Clearing trees, another way of destroying frog habitat and the species that live in those areas. The area moves. Cattle destroy it. And this is what happens in the high country in Corroboree frog area, where this used to be the bogs. It is no longer a bog and there's no longer Corroboree frog living in this area. It's just been trampled to death. The sides of streams, this is again in the high country. You see the damage that the cattle have caused up in there. Even oil slicks coming into drains off the roads because it gets into the waterways, detrimental to frog species. Litter, we've found quite a few frogs tangled up in plastic bags. This is the result of ultraviolet radiation in Japan, an 8-legged frog, and another reason why we've got to look after the air and our environment around the globe. Don't eat frogs' legs. But this is the way they are marketed. In America, SaveTheFrogs.com have literally got about 3 food chains in supermarkets and so forth to stop selling frogs' legs and whole frogs like this because it moves disease and pathogens around. Well, clean habitat, as I said today, clean habitat means healthy frogs, another healthy wildlife as well. My main work over the last 5 years has been chytrid fungus. Chytrid fungus was introduced into Australia in about 1926 from Africa, by the African clawed frog. And why it was brought into Australia was that during that time there was a very difficult way of telling whether a woman was pregnant or not early in the pregnancy. So what they used to do was to get this frog, inject some urine from the woman into this frog. If the frog ovulated, the woman was pregnant. pretty primitive sort of system, but it worked. But unfortunately, the frog carried chytrid fungus with it. And unfortunately again, it was, particularly in Victoria, a lot of those frogs were brought to Melbourne Zoo and bred in Melbourne Zoo and then transferred right throughout the world. So they just spread it everywhere. This is the result of one frog that has chytrid fungus. It literally dehydrates until it mummifies and dies. They can get ulceration, although that's fairly rare. Most times they just shrivel up and die. There's at least 100 species now that have completely disappeared, totally extinct because of chytrid fungus throughout the world. 6 of those are from Queensland, totally gone. The work that we did in the southwest, we did 150 sites. We found 10 sites with chytrid fungus. Although we could not say the other 50 sites, the other 140 sites didn't have it because we didn't find enough frogs to actually say they were negative. In fact, in one area from Lake Ballarat down to Warrnambool, we spent a whole week doing surveys down there and literally in that 1 week found 3 frogs only, and they all turned out positive. This is a devastating disease, and potentially it could wipe out all frog species right throughout, not just frogs, but all amphibian species right throughout the world. This is the distribution in 2004, and the amount of animals that were in wild populations and captive populations with chytrid fungus. But then when we got up to 2006, it spread quite dramatically. We now have over 50 species in Australia have been found to be positive out of the 300 odd species we do have. This is the African claw frog, and it's only a small frog. In South Africa, it does seem to have an immunity to chytrid fungus. It sure has a devastating effect on the rest of the planet. What we did was to try and develop a protocol for mapping chytrid fungus in Australia, and working along with James Cook University in Queensland, where they were swabbing northern Australia, try and find this frog fungus. We concentrated our efforts on southwestern Victoria to find out where it is down here. We received $50,000 from the Glenelg Hopkins CMA to map where chytrid fungus was found. Unfortunately, it's very extremely expensive. For every swab you use is $1, but it costs $45 to have that swab tested. So when you're looking at about 1,000 frogs, out of your 50,000, 45,000 is already gone. So it's extremely expensive to try and do any research on this. We chose bioregions within the CMA area to determine which species were present within that bioregion, and to try and determine the distribution of those species, which we picked quite a few. That's from James Cook University. Then to determine whether all amphibian populations are infected, and we found they're not. It's only along the coastal areas where it's moist. Once you get out into the drier country, chytrid fungus, even though it is a devastating fungus, it really is quite delicate. It doesn't like salt over 1500 EC. It doesn't like being too hot, over 28, 30 degrees, it doesn't like it. Under 5 degrees, it doesn't like it, it dies out as well. But it can stay dormant in frog species over those cold periods and over those hot periods, depending on what the frog does to determine its survival. Whether they go underground, for example, growling grass frogs in some of my areas down near Ballarat, during the hot, dry summers when those ephemeral wetlands dry out, they literally go down into the yabby holes, particularly the dryland yabbies, which make these big chambers underneath the ground, but they're usually half full of water. So the growlers get down in amongst those yabbies during those dry summers until the favourable conditions come back again. Chytrid doesn't like temperatures below 17 and over 25 degrees, so when you're looking for the fungus and you start collecting frogs to swab them between those temperatures is the ideal time. Otherwise you can pick up a positive frog, which is not dispersing spores out of the skin, say under 17 degrees. You can swab it and get a negative result, which is not what you're looking for. So you've got a very small window of time to actually do the testing to find out whether an area is positive or negative. Also determine the salinity of those areas that you're swabbing, because if you've got salinity at around 4,000 EC, it's absolutely useless trying to do swabbing in there. It's just a waste of time and money. This is chytrid, what it looks like. In the capsulated area, the capsules get quite large, and then put out these funnels, and then to start dispersing the spores, which usually come out of the skin, and then are waterborne and picked up by other species of frogs. This is what it looks like after you take the skin off a frog. This is chytrid fungus, just underneath the skin, a little bit there, when it's first starting off. This is 2 weeks later, where it literally makes a mat underneath the skin, which stops the transfer of oxygen and moisture through the skin, so the frog dehydrates and dies. There are other factors included as well, but this is the main one. In tadpoles do not suffer from chytrid fungus, but they carry it. The little white areas just there, there and there is chytrid fungus. You can swab tadpoles' mouths to try and pick it up. It's a lot more difficult, so it's easier doing it with the frogs. Once this tadpole then turns into a froglet, then chytrid fungus will start taking over because it's only prevalent in keratin, which is in the frog's skin. This is the yellow-legged frog in California in America. This is only one slide of about 3,000 frogs that were found in 3 weeks. Just literally wiped out the whole species in that whole area. So as they say, extinction is forever, and this could be quite devastating. The giant bar frog, which has got it, just before it died, about a week before it died. This is the area that we covered, all those basins. We tried to cover every one of those basins, so we got a general outlook over the whole of the Glenelg Hopkins area. So we had 150 sites over the whole area. The first thing is trying to find frogs. You try and find one. So the best way we did it was we utilised two methods. One is we had about 3,000 of these wooden untreated pine, because treated pine will kill frogs. We put these blocks of wood down all over the place. This is in the Grampians, this one. But we also utilised DSE's 15,000 roof tiles over the whole of the Western District, which worked very well. The frogs get underneath them, use them as refuge areas. It's nice and easy to come along, lift up a tile, find a frog, swab it and put it back. We did have a Japanese intern for 12 months. She was learning from us about chytrid fungus and went back to Japan. At that stage, they didn't have chytrid fungus, or they didn't know of it. But once she started working in Japan, particularly around the Nara area, she found it quite prevalent, and particularly in pet shops. So they were selling amphibians as pets, and a lot of them had chytrid fungus. This is the swab we use. It's only available from UK. Costs $1 per swab. This is a constructed wetland over at Miners Rest, just northwest of Ballarat, where they utilise the local creek. Half the creek water comes into these wetlands and goes out the other end. It's for taking stormwater off a subdivision housing area. And the water that's going back into the creek is actually cleaner than the water that's coming into the creek because of the vegetation that's in there. I helped design this wetland and it works very well. Here we are swabbing green southern brown tree frogs. We do use latex gloves and we dispose of these after each frog that we swab. mainly because this frog could be carrying spores of the chytrid fungus, and we don't want to go spreading it from one area to another. We are very conscious of field hygiene as well. For example, we use a thing called F10, which is a veterinary disinfectant, and we use it into a foot bath, a piece of sponge within that bath, and F10 and water within that. We just use it in our feet. If we've been walking around the wetland itself, we get wet feet or muddy feet. It kills off chytrid fungus. It also kills off Phytophthora and Malaria as well. So it's really great. But firstly, we used to use bleach, which is very effective too. But when it starts spilling on your carpet in your car and turning it all white, we decided to give that away and also destroy your boots as well. So particularly in Waterwatch people put their little meters and things in water to determine pH, salinity and so forth. If that is not disinfected before it goes to another spot, you could be introducing chytrid fungus to a clean area. So it pays to disinfect all your materials, all your machinery and your footwear. If you do happen to drive your vehicles into a wet area that could be carrying chytrid fungus, a spray bottle with these disinfectants on it, just spray around your wheels and underneath the car to try and not transfer these spores. Is there immunity to it? At this stage we don't know. There seems to be in the clawed frog in Africa, and common froglets seem to withstand chytrid fungus, but over the last year, when we had really high rainfalls and a lot of water all over the place, the frog populations have increased dramatically, absolutely dramatically. But we don't really know whether that's a false population because instead of normally breeding once or maybe twice, even growling grass frogs last year down south bred 4 times. So you have an extra income of young coming out of the water, and at this stage it looks like there's a very good population of frogs through the whole district, even in the North Central. And we really won't know for 18 months whether that's going to remain stable or whether there's going to be a huge crash, because we really don't know where chytrid fungus is in the North Central. Only one spot that I know of, and one I've been monitoring for 35 years, is the Creswick sewage ponds, and I've been looking at growling grass frogs there for 35 years, and there's been a stable population of males there over that time. Last year we had floods from the creek, which is next door. They came through, covered up all these evaporation ponds with water, and now there are no growling grass frogs left. Out of about a population of about 3,000 frogs of 5 different species, we now have probably about 50 frogs left. Chytrid fungus, and we did have them tested. Chytrid fungus has come in and just about wiped the whole population of everything. So it can be quite devastating. And this is why I say the importance of field hygiene is extremely important. The zoos do keep endangered species for breeding in the hope that if something does become extinct in the wild, they can release some of those species, and they have been doing. The corroboree frog, for example, has been bred in zoos, and some have been released back up to areas that they have declared free of chytrid fungus, and hopefully that works. And it's called Amphibian Arc, which covers quite a few of the world's zoos, not just in Australia, but right throughout the world. As far as growling grass frogs go, DSE do have a program called Dams for Habitat, which are planting up dams to entice growlers to take over those dams and breed. They were assessing dams that did have growlers in them so that they can find dams around that area that don't have the right habitat, so they can approach those farmers and landholders so they can plant up those areas, fence off some of the area and try and get the population of growlers a bit higher. But again, we really don't know whether some of those areas have chytrid or not. There's lots of different sorts of frogs right throughout the world. Some extremely large, like the Goliath frog gets about 2.5 kilos in weight, absolutely huge. Right down to the smallest one, which is found in New Guinea just recently, which is about 7 millimetres long. It's really tiny. well, as it says, even there it says extinction is forever. And it would be a sorry world if we lost amphibians right throughout the world. They are important. They do eat insects, including things like mosquitoes, and which is really important now for things like Murray River encephalitis, malaria further up north and so forth, which is now starting to build up in number. A lot more people are getting these diseases through a lot more mosquitoes transmitting those diseases around. Again, as has been mentioned before, they are a food source for lots of other animals. And there are medicines which are found on compounds from frogs. Particularly there's one up in the Kimberley area which they've found some compounds in that frog's skin which can help, not cure, but help with AIDS. What can you do? Well, it just means living clean, reduce, reuse and recycle. Don't use chemicals that do hurt the environment. And together we can save the frogs. I'll leave it there.